Hello and welcome to our trust project discussion. My name is Aditya Silas, and with me I have Jared and Wesley, and Patrick will be joining soon. We were Team 9. We did the How Truss, and we were How Mandel. So, for designing and building the truss, I would say that the build part of the designing and building the truss was actually pretty easy, but then we had to mark and cut the truss and put it together in like these precise measurements. And we were using a lot of calipers here, and that was the main challenge, which I guess is the nature of engineering, and that we have to be like precise when we're doing all of our work. But we work well together as a team, so it was just trying to get it precise and like trying to glue everything properly together and build it and cut it together. So yeah. In the future, if we were going to do the truss again, I would just like redesign the truss and like make it taller because as you will see later on, taller trusses often are stronger. So
Okay. Um, so we had to build a CAD model for our truss so that we can spec it out with our cross section, orientation, height, and given constraints. So we concluded on a truss looking like this. It is modeled after a Howe truss, 6 inches tall and 23 inches long. We ultimately ended up making custom gusset plates to optimize the surface area of the gluing surface because we're only allowed to cover 15% of the length of the member with each side of the gusset. Um, Ultimately, I think this helped our truss performance in that our glue joints were able to be stronger. But also ultimately, our failure was at the gusset plate at in shear. This is how our actual model turned out. Um, As you can see, it's very similar to how our CAD model looked. We went into the wood shop, measured out our members, cut them on the bandsaw. We laser cut our custom gusset plates, and then we assembled it via glue and clamps.
So the actual calculations and the trust performance was difficult to get to, but I think we did rather well when it comes to the calculations. We predicted a failure load of about 637 pounds, and it was an actual load of 404 pounds, and it was at the correct joint and with the correct failure type, which was gusset shear failure at joint E. So that was about 35, 37% percent error. And getting to that point with the calculations was time consuming and difficult, and there were a lot of points where we felt something was wrong with the calculations because it just we didn't think it would be possible to get some of the numbers we got, and clearly it wasn't all wrong as we predicted parts correctly, and I got rather close. Next, we'll show you the video about or with kind of how the failure worked and how we failed. There we go. There you go. 400, 200. What is that? What is having a blue share? So maximum load 404. So as you can see, as we're hearing you hear us talk about there, the maximum was 404. And while you can't really notice it there, what essentially happened was it split off and it was literally like you could pull it off. Um, and you could. And that was kind of what happened there. So then some analysis and the performance comparison. So between the two truss teams that held the most load between the two sections, on 0401, we had Team 10 beam me up with 1,007 pounds. And in 0301, we had Team 1 with Big Truss with 828 pounds. Between the least loads for 0401, we had Trussell Cookies with 283 pounds. And 0301, we had In God We Truss, 156 pounds. The in 0401, the team with the highest strength to weight ratio was Beam Me Up with 1,000. We don't have the ratio with us. Um, the lowest in Team 11 was uh, Trussell Cookies with a ratio of 320 pounds per pound. And I'm sorry, for Beam Me Up is 1,120 pounds per pound. In the 0301 section, the highest was Unwarranted with a ratio of 977 pounds per pound. And the lowest was Tailor Made Truss with 247 pounds per pound. So relative to us in the other section that did the How Truss was Trust the Force. They held less load and they said glue shear, so we are going to assume that they had the same fail type, and we don't know about location. They didn't specify. So I think some key takeaways we had during this is the overall our section did support more weight and our section used red oak. And so we think that red oak is the better wood to use for construction. And the taller the trusses were, generally the more weight they could hold, which I kind of makes a little bit of sense. I mean, you've got more stuff there. And then, I mean, personally, our patterns was that if you dressed up and you played into the theme and you really got hyped for it, you just did better in the dress project. And then we'll be passing it off to Patrick to wrap us up.
During this entire project, we went from being friends in class to actually applying our skills that we had been learning throughout our short engineering careers and our current mechanics careers at UMD. And so with that, we had to work together to not only design our truss using computer aided design and to figure out all the measurements and how we were going to maximize our 15% surface area for our gusset plates, which our team member Jared figured out, and it worked very well for us. And working as a team in the wood shop when we were actually constructing our truss, we had to work together to split apart the measuring and the marking of our pieces of wood in order to get exact measurements to actually construct our truss so it would fit our CAD design and doing that, and then also figuring out the best way to glue the truss together took a lot of brainstorming from everyone in the group and figuring out how to do it in the most time efficient way while also not compromising the structural integrity of our truss. Communication was also a big thing as we used our group chat to figure out when we were going to be building our truss, who was going to take what responsibilities, and then also for this project, being after the final and many people going home, using it to figure out when we were going to meet, when we were going to figure out how to construct a slideshow and get these videos recorded, do the calculations, and so communication played a huge role, especially on the back half of this project. Our engineering skills, while we have learned quite a few through our lifetime, we are still very young in our UMD engineering careers, but we were able to apply skills that we learned in our mechanics class with the calculations for buckling, shear stress, and analyzing a truss and figuring out the force in each of the members via using method of joints, and also engineering skills from other classes such as calculus or ENES 100 and the engineering process by looking and figuring out the best way to do something and prototyping and also figuring out how we can work together in the most efficient way. Practical skills, I believe that this project was very keen on that. And as a team, I think we all believe that we were able to be in a wood shop and actually have hands-on experience with what we had been learning in class. And when we were doing this, we were able to use band saws and cut the wood and actually measure out and get really exact with the tools that they had in the wood shop, as well as assembling it using glue, kind of working together to hold all the members in place as the gusset plate's glued, and really having a hands-on experience that is very practical and will help everyone in our team in the long run in their engineering careers.